Write g of t equals 0 if t is less than 1, t minus 1 if t is between 1 and 2, and 3 minus t if t is greater than or equal to 2 in terms of unit step functions. For me, the easiest way to figure out what step functions I need is to draw a graph. Here's the graph of g of t. From this picture, we can see that we want two steps to happen. A step up at t equals 1 and a step down at t equals 2. So our answer is going to involve the unit step functions u of t minus 1 and u of t minus 2. But we aren't taking full 1-unit steps. Instead, we are stepping up gradually. We can determine the size of each step by comparing the formula for g of t before and after each step. At t equals 1, the formula changes from 0 to t minus 1. So the function steps up by t minus 1 minus 0 equals t minus 1. We can describe this with a transformed unit step function u of t minus 1 times t minus 1. Then at t equals 2, the formula changes from t minus 1 to 3 minus t, which is a change of 3 minus t minus t minus 1, which equals 3 minus t plus 1, so negative 2t minus 4. So we're stepping down by 2t minus 4, which we can represent with the transformed unit step function u of t minus 2 times negative 2t minus 4. Putting the two steps together, g of t is t minus 1 u of t minus 1 minus 2t minus 4 u of t minus 2. I like to think of the step functions as switches that don't turn on until a specific value of t. So for our function, until t equals 1, both switches are off and the output is just 0. But once we hit t equals 1, the first switch turns on, and now the output is t minus 1. Then finally, when we hit t equals 2, both switches are on, and the output is t minus 1 minus 2t minus 4, which equals negative t plus 3.